Hello everyone and welcome to another Physics 210 lab simulation walkthrough. As always, my name is Alec Lancaster. Today we're going to be having a talk about pendulums and measuring the acceleration due to gravity on the Earth, as we have done many times before, by way of, swinging some pendulums around. Alright, so before we jump in, please make sure that you have read through the lab manuals theory section and that you understand it as well as you can before we get going here. So once you've done that, go ahead and open up this simulation and you can follow along if you like, or of course you can use this data as your own if you feel the need. So first we're going to do an experiment varying the pendulum bob mass and see how that affects the time that it takes for a pendulum to undergo one period. So keep in mind, please, that one period of a pendulum, actually I'm going to stop it, if I swing it out here, one period is when it goes back to its original point. So it's when it goes from here to here and back. So one period is one full swing of the pendulum. Alright, so let's go ahead and get into the lab for today. It says to set the length of the pendulum to 1 meter, which I've done here. Set gravity to Earth, because that's where we are. Great. Check the stopwatch button, which will pop up this handy dandy stopwatch. And set friction to none, because we want to kind of idealize this for ourselves a little bit. And ensure that you only have one pendulum on the screen. You can, of course, do this experiment with two pendulums if you like, but things get a little messy, as you can see. So, for the first part of the lab, we're going to be varying the mass. So first we're going to set it to 0.1 kilograms, or otherwise known as 0.10 kilograms, or 100 grams, whatever you prefer. Click on the pendulum and drag it until it reaches an angle of 10 degrees with respect to the vertical, which is nice. And what's nice about this simulation is that it'll actually tell you the angle right up here. So it's actually fairly easy to do that. So we're going to let it swing a little bit, and now it says to let go and let it swing. And because there's no friction, it should swing like this indefinitely. Which, if we sat here for 20 minutes, you would probably be fairly convinced of that. But I'm not gonna make you do that. Now it says check the slow button so that it slows things down. And what you'll notice here is that if I start timing, the timer is actually slowed down on the same scale as the simulation is. Now if I speed it back up, you'll notice we go back to the original timing. So we're going to do that in order to be able to make some more accurate timing measurements. And now it says when the pendulum reaches ostensibly here, click play on the timer and start recording. So what we're going to do is record the time that it takes to go through one period 5 different times. Okay. Now we're going to leave the timer on continuously through. That's all started here. And I'm going to speed it up just really quickly. Okay, so it's finished its first period at about 2 seconds, and then it's finished its second period around 4 seconds. Finished its third period around 6 seconds. Finished its fourth period around 8 seconds, and its fifth period around 10 seconds or so. Okay, so do keep in mind that 10 seconds, of course, is not the length of one period. Go ahead and mark down, okay, on the first period it was 2 seconds, second period 4 seconds, and all of that. That would mean that the second period took a total of 2 seconds, right? So go ahead and keep that please keep that in mind as you're doing this. But ostensibly, basically what we just measured is that the average period length of one oscillation is about 2 seconds. But it says to record the time it takes for the pendulum to complete 5 successive periods, which we just did, noting the time after each individual period. Great. And then to calculate the average period of the 5 periods that you just recorded and the uncertainty of that period. There's a lot of periods in here. Apologies for that. So once you've done that, go ahead and calculate the average length, or the average time of one period from that data set that we just took. And then we're going to repeat steps 2 to 7 with bob masses of 0.2 and 0.3 kilograms. So I'm going to go ahead and up the mass to 0.2, and then we're going to go through that again. Again, we're going to set it to 10 degrees, let it swing for a little bit, and then I'm going to slow it down right before it hits, and then we're going to start recording right now. All right. So after the first period, we have about 2 seconds or so. After the second period, we've got about 4 seconds. After the third period, about 6 seconds. After the fifth period, about 8 seconds. Or sorry, that was the fourth period. After the fifth period, about 10 seconds. All right. So go ahead and use that to calculate the average period for the pendulum at 0.2 kilograms. I'm going to go ahead and up it to 0.3. bring it back to 10 degrees, and we'll allow it to start swinging. All right, so after the first period, we're at about 2 seconds. No surprise there. After the second period, we're at about 4 seconds. Third period, 6 seconds. Fourth period, 8 seconds. And fifth period, about 10 seconds. So go ahead and mark that down, and again, calculate the average. If you want to use again, I was using kind of my eyes just to, figure where exactly it was as it was going. But if you want to make it more accurate, you can kind of like 12.2 or whatever. But so if you want to try to get that fine with it, you probably can with a slow down time. I just wanted to make sure I got my I just wanted to make sure this video didn't take 20 minutes and that YouTube would get mad at me for that. So let's continue on after that. Now we're going to vary the angle at which we drag this thing up to. So, ostensibly the period might get longer if the angle is more, if we have more, if there's more of an angle in there, right? So the procedure is pretty much the same as before, and the setup is exactly the same as before, except that we're going to set the mass of the bob to 0.2, and we're going to leave it fixed there the entire time. Now it says to perform steps 2 through 7 of the above with angles of 15, 20, 25, and 30 degrees. So I'm going to reset this, and I'm going to set it to 15 degrees this time, and let it go for a sec. And I'll slow it in a moment. All right, and I'm going to start. So after the first period, we're looking at about 2 seconds. After the second period, we're looking at about 4 seconds. After the third period, about 6 seconds. After the fourth period, around 8 seconds. And after the fifth period, around 10 seconds. So I'll go ahead and stop everything, reset the timer, and now we're going to set it to, we're going to set it to 20 degrees. So there you are. Slow it up, and start. All right, so after the first period, we're at about 2 seconds, no surprise there. After the second period, around 4 seconds. Third, we're at about 6.1, it looked like. Fourth, around 8.1. Fifth, close to 10.1. All right, now up to 25 degrees. We'll let it go. I will start the recording now. All right. So it looks like we got about 2.1 or 2.2. Looks like about 4.1. 6.1 between that and like 6.2. About 8.2. And 10.2. All right. So now we'll drag this up to 30 degrees, which I believe is our last one for this section. Yep, okay, great. And I'll slow it down, start the recording once it gets up there. Perfect. All right, so first period, about 2 seconds. Second period, about 4 seconds, maybe 4.1. Third period, around 6.1 seconds. Fourth period, around 8.2 seconds. And fifth period, around 10.2 seconds. All right, great. So record all of that, and also add in the measurement that you made before at 10 degrees with 0.2 kilograms, just because we already did that one before, so why make ourselves do it again? And this time we're going to vary the length of the pendulum. So the length of the pendulum we can set between 0.1 and 1 meter. So we already made all those measurements at 1 meter, so I don't think we're going to be making any measurements at 1 meter here. But for now, set the mass of the pendulum bob to 0.2, which we've already done, and we're going to leave the angular amplitude fixed at 10 degrees for this section. Now, we're going to repeat steps 2 through 7 of the above with pendulum lengths of 0.9, 0.8, 0.7, and 0.6 and 0.5 meters. So let's go ahead and do that. Bring this down to 0.9. And let's go ahead and fire it off. All right. We're going to start the recording right now. All right. All right, so it looks like about 1.8 there, maybe 1.9. About 3.8. About 5.8. About 6.7, or 7.6, sorry. And about 9.4. So if you need to watch that again, go for it. And those are some weird numbers. I'll actually drag it up here so I can see it a little easier next time. Now we're going to decrease the length of the string to 0.8, and we're going to do that again. Start. All right, so it looks like about 1.7, maybe 1.75, about 3.5, about 5.3, about 7.1, and then about, oh, drat. All right, so you got those ones, you got those first four, right? I'm just gonna record one more, and also this way you won't have to do the math. All right, so let's see here. I'll start it now, and I'm just gonna record one more period because you need 5 data points. So this one's about 1.75. Okay, so now we're gonna move on to 0.7 meters, and let's see, drag it up to 10 degrees. Start recording now. All right. So looking at about 1.7 for the first period, about 3.35 for the second period, about 5.1 for the third period, for the fourth period about 6.7, and for the fifth period about 8.3, maybe 8.4. Awesome. Okay. So finally, we're going to bring the length down to 0.6, or not finally, penultimately, down to 0.6. And start the recording. For the first period, we've got about 1.5. Second period, we've got about 3.0. Third period, about 4.5, maybe 4.6. Fourth period, about 6.2. Fifth period, about 7.7. All right, now finally down to 0.5 meters. Oh, and we'll start here. Start the recording. All right, about 1.4 for the first, about 2.8 for the second, about 4.2, maybe 4.25 for the third, about 5.8 for the fourth, and about 7.2 for the fifth. So there you go. That should be all the data you need. You should be able to calculate all those average periods and all of that. Just make sure, again, when you're calculating those periods, that you subtract from the original. So like this, if the second period, ended at 4 seconds, make sure that you subtract the first period, which ended at 2 seconds, from that to get your actual period length. And then, so that should be all you need to go ahead and do all the data analysis and answer these questions. And once you've done that, you can go ahead and submit your lab report. As always, if you have any questions for me, feel free to email me or come by my question section from any weekday from 1 to 2 p.m. Or you can email me and we can set up an appointment to meet. And yeah, anyway, have a great day.